So, as I was saying, because I totally did not forget to start recording. If you guys last year were doing division, now I can't talk. You guys would do one of two methods, either the traditional algorithm or what we call partial quotient. Both are viable, both work, and I'm going to show you both of them real quickly, okay? Because regardless of what you would do, you guys still got to the same point and you stopped at the same approximate area. So for example, traditional, I'll tell you what, let's do the traditional in green. So 17 does not go into 3. 17 goes into 37 twice. 2 times 17 is 34. Let me know in chat if this looks familiar. 32, it goes in 1 time. 17, subtract 15. You would say something like this. 21 remainder 15. Okay? How many of you do it this way, the traditional way? Okay, good. The other way, the partial quotient way, I will admit, I think it's nifty. I like it. I'm going to do this one in red. However, it comes with an issue for stuff in 6th grade. So when I look at partial quotient, I'm going to look at it. I'm going to say, I can pull out, well, simple math, 10. 10 groups of 17 from 372. 10 times 17 is 170. Please come back, problem. Thank you. I'm going to subtract 2, 0, 2. I'm like, oh, wait, that's really awesome because now all of a sudden I know I can pull out another 10 because that's another 170. So I'm going to pull out 10 more. And I get down to 2, 3, and 0. Like, okay, how many more can I pull out of 32? I can pull out 1 more. 17, 15. So I add this up. 10 plus 10 plus 1 is 21, and I have a remainder of 15. Same answer, 2 completely different ways, right? Everybody with me so far? How many of you, all right, so we're going to do this. Give me a 1 in chat if you prefer the traditional method. Give me a 2 in chat if you prefer partial quotient. Okay. So here's what I'm going to say. When we are looking at, no, it's not illegal. You could totally like both. I like both, but I like both based off of the conditions that I'm doing. If I don't need to worry about decimals, I kind of like this one. I think it's fun. I think it's creative. It's completely different, and I can explain a lot better what I'm doing conceptually using partial quotient. Pulling out 10 groups of 170 makes sense to me. Okay? Whereas up here, I'm like, okay, so I'm not really pulling out groups of anything, right? And really, I'm not pulling out 2 from 30 or 37. I'm pulling out 20 from 370. That one gets a little bit more squishy, okay? So if I need to do decimals, however, like I'm going to be honest, we did what was called drill and kill when I was in school. Drill and kill. I was given a worksheet of like 40 problems, and I had to do this. And I had to do it 40 times, and it was literally beaten inside of my head. It was painful. But eventually I got to the point that I could do it. Now, I can explain, me personally, very comfortably, the steps to dividing decimals using the traditional method. I have tried with partial quotient and it gets real nasty. Okay. Because in 6th grade, this right here and this right here, the remainder is no longer acceptable to write. Okay. I want you to completely divide out your problems. So we're going to do this problem one more time. 372, 17. All right. Let's get the purple back. And I'm going to use the traditional method, and I'm going to show you how far I want you to take this problem. Okay? So 1737, we already said it goes in twice. That's 34. Bring down the 3 and the 2. It goes in once. 15. Oh, nope. Once. 17. Remainder 15. But we're not writing remainder 15 anymore. Thank you, Zach. So if we're not writing the words remainder anymore, what are we doing to solve and answer our problems? Well, ladies and gentlemen, this is where the decimal comes in. And I'm going to have you watch a video on Khan Academy that does a really, really good job of explaining everything about this. And I know how some of you feel about Khan Academy. That's fine. Okay. But this is a really good video that I would basically teach you how to do it the same exact way. What we need to remember, the number 372, okay? This is my ones, this is my tens, this is my hundreds place, right? When we go back to place value, what is always right next to the ones place value in every single number that ever exists? Ever. Well, we have a decimal because we have our tenths, we have our hundreds, we have our thousands. Do you remember your place value charts in 5th grade? There is always a decimal right here to the right of the ones place value because it separates whole from partial numbers. So if I have a decimal right here in 372, I have a decimal right here in this 372. Do we always write it? No, because we don't need to. I don't have any part of a number, so I don't write it, but I can. And that's where this math comes in. If I put my decimal, I can put a number. Whoop, I dropped my pencil. I can put a number after it. I'm back. Hi. How many tenths do I have in the number 372? Well, here's the answer. Not tens. Sorry, not tens. Tenths. How many tenths do I have in 372? Here's the answer. If we don't write it, we don't have any. And what number represents not having anything? 0. Okay. So I have 0 tenths. I technically have 0 hundredths, 0 thousandths. I could write an infinite number of zeros after my decimal place. What does that allow us to do in our division problem then? Well, if I can put a 0, I can put a 0 right here. All of a sudden, that allows me to continue my problem and to bring down another 0. 17 goes into 150. Oh boy. Let's try 17 times 9 because I don't know. 3, 6. That's 153. Ah, it's too much. So I know it's 8. 17 times 8 is going to be 6, 5, 136. Okay. You see how I'm doing a little scratch paper, scratch work there? You can do that. That's allowed. So it goes in 8 times. 136. Subtract 14. Oh, no. I didn't solve my problem. That's okay because I can add another 0. I add another 0. Look at this. That goes in 8 times 136 because I'm using my little cheat sheet right here. Leaves me a remainder of 4. Do I know how far and how long this problem will go on? I do not. I just cheated. It goes on for a very long time. Okay? The point that I'm trying to make is I can add as many zeros as I want here and keep dividing out. Okay? You can put as many as you want. Now, what's going to happen is you're going to find a lot of the time it's going to tell you to round to the nearest 10th or round to the nearest 100th. Okay? So we'll deal with that later. What I want you to understand, though, is this part right here is probably something that many of you didn't realize. And this is why we teach place value in 5th grade. I can add more place values because I just put in a 0. Tenths. Last step is I need to put a decimal because 17 does not go into 372 2,188 times. Well, ladies and gentlemen, this is the super easy, and this is why I like you working on your paper turned sideways so you keep all of your numbers in a nice, neat row. The decimal literally just follows the line up. So my answer, 372 divided by 17 is approximately 21.88. I'm saying approximately because it doesn't equal it. All right? Because it's approximately that. It doesn't stop. I could have kept adding zeros and getting all of this, and I'm going to let you in a little secret. It doesn't stop right here. It just rounded to the last point because it ran out of room on my screen. So your takeaway that I want you to have from today is division is likely, when you do a problem, you are likely to get an answer that you're going to have to round because division doesn't really ever stop. There are some problems where it's nice and neat, and you get 36 divided by 9 equals 4. Done. But a lot of times you're going to get stuff like this, and it doesn't work out neat. Okay? Same steps as normal division, but you can add on decimals. This is why I prefer traditional methods versus our partial quotient. Because when you start getting into partial quotient, you're going to get to the point that you can't do this anymore. Like, you're going to have to figure out what you multiply 17 times to get it to be smaller, and you're going to be multiplying by decimals, and it's nasty. It is so nasty. So that's why I kind of push you towards traditional. Come back problem. Now, I'm going to post this video on It's Learning. You will be able to rewatch it to your heart's content. What I want you to do right now, this was an exploration in math, okay? I threw a bunch of stuff at you. Some of it's going to stick. I'm going to have you watch the Khan Academy video that is going to show you exactly what you need, okay? I'm just trying to get you to understand that if you don't use the traditional method, you need to kind of switch that way. You know, if you guys have stopped talking in chat and just saying, I'm lost, I'm confused, I lost a brain cell, and actually tried to listen as opposed to type a message, you might figure it out a little bit better. Just saying. Ladies and gentlemen,